Welcome back. My name is Palaj Biswas, Assistant Professor, JS College of Engineering, Department of Mechanical Engineering, and also today discuss the coloring of this topic is under the subject of computer aided design, and also this is my lesson number 22. And color, the color is basically the COLOR. This color is comes from the American English, and also or color COLOUR. This will be comes that like your the Commonwealth English is considered is the characteristics of visual perceptions described through color. That like your the color categories the with names such as red, orange, yellow, green, blue or purple. That is the different color is considered according to this is the name is given is here, and this perception of color derives from the stimulations of the photoreceptors changed by electromagnetic radiations will be considered according to your the different type of colors will be comes during to your the stimulations of photo receptors, and also this is the considered according to the electromagnetic radiations. That like the color categories and physical specifications of color are associated with the object through the wavelength of the light that is reflected from them, and their intensities will be considered according to this type this color. The another things will be comes here. This reflections is governed by the object's physical properties such as light absorptions, emissions, spectra, etc. is considered according to your the different type is this case of this your the reflections. And another things is find the physics of color. The basically the physics is color is calm. That means your the electromagnetic radiations is characterized by its wavelength. That like your the wavelength. The you have to measure that is the wavelength, that like your the frequency and its intensity is considered according to your the physics of color. And when the wavelength is within the visible spectrum is considered that like your the wavelength, and this spectrum the range of wavelengths humans can perceive the approximately from 390 millimeter nm to 700 nm place your the uh, it is known as visible light. The what is your the visible lights, and that means your the human can perceive approximately from the 390 nm to 700 nm is here. This is considered your the visible lights. The most light sources emit light at many different wavelengths is comes. That like your the light sources emits light at many different wavelengths. A sources spectrum is a distribution giving it's the intensity at each wavelength is considered according to your the physics of color. And although the spectrums of light arriving at the eyes from a given direction determines the color sensations is comes here. In that directions there are many more possible spectral combinations that color sensations is comes, and like your the sensations in that direction there are many more possible spectral combinations that color sensations is comes here. In fact, only may formally define a color as a class of spectra that gives rise to the same color sensations is comes. That like your the same color sensation is comes. Another things, the although such classes would vary widely among different species and to a lesser extent among the individuals within the same species is considered. In each such class, the members are called the meta metamers of the color in questions. That like your the metamers of the color is in question. This effect can be visualized by comparing the light sources. That like your the light source is the best color is the considered according to your the natural lights is comes from your the sun, the spectral power distributions and the resulting color is comes here. The spectral colors is the considered the familiar colors of the rainbow in the spectrum. That means your the rainbow. This will be known the all students that like your the childhoods you can know the what is your the rainbow. That is the comes from your the different color. That means the seven color combination is considered as the rainbow. And another this name using the Latin words or appearance or appreciations by Isaac Newton in 1671 includes all those colors that can be produced by visible light of a single wavelength only. The pure spectral or monochromatic color is comes. During to this, the colors of the visible light spectrum is considered according to different color is given here, and also the wavelength interval and also the frequency interval is given this table. The first we can see that like your the red color is comes that like your the wavelength interval is the 700 to 635 nm, and frequency interval is comes here that like is the 430 to 480 TAZ is considered. And according to this the orange this one is the wavelength is interval is comes here that like the 635 to 590 nm, and frequency interval is comes that like the 480 to 510 TAZ, and yellow color is considered that like the 590 to 560 nm, and frequency interval is comes that like the 510 to 540 TAZ, and green color is considered that like the 560 to 520 nm, and also the frequency interval is comes is the 540 to 580 TAZ, and uh, cyan color is considered that like the sky blue is the 520 to 490 nm is here. You can see that like your the blue color is comes the 490 to 450 nm, and also the frequency interval is considered that like the 610 to 670 TAZ, and the violet color is considered that means your the 450 to 400 nm, and also the frequency interval is come that like your the 670 to 750 TAs, and this will be considered according to your the this table the color the visual lights spectrum is considered. And this table at right shows this will be shows the approximate frequencies and wavelength, and also the nanometers for various pure spectral colors. The wavelength listed this will be already discussed in this tables. The color table should not be interpreted as a definitive list. The pure spectral colors from a continuous spectrum, that is the how it is divided into the distinct color longitudinally is a matter of culture, and the historical contingency is considered. A common list identifies the six main bands that like the red, orange, yellow, green, blue and violet color is considered, and the Newton's conceptions is here included a seventh color indigo between the blue and violet. That like the seventh color indigo is considered the blue and violet between this the blue and violets. That like you can see you can just like your the blue and violets will be considered according to this. And the intensity of a spectral color is that is the comes from the relative to the context in which it is viewed. That like your the many alter is considered it's the perceptions considerably. For example, a low intensity orange yellow is brown orange, no low intensity orange yellow is considered as the brown, and the low intensity yellow green is olive green is considered. That means your the that is the intensity is considered the one type of example is here. The color is the low intensity orange, that like your the yellow orange yellow is brown, and the low intensity yellow green is olive green is considered. The you can see the this will be the color wavelength frequency and the energy of light is discussed on this. The table is here, that like the first is here, that is the color, and also the displaced, and the this is the LA, the lambda is here, that is the lambda, and also the displacity is it's considered nu is here, that like the THZ, and also the displacity the nu is another is here, that is the micrometers is considered, the LV is the EV is considered, the displacity, and also the energy is considered according to this, just like the color wavelength frequency energy of a light, just like is considered. That is the infrared ray will be here, that is the lambda is considered is greater than 1000, and also the frequencies comes with the less than 3000 and 300s, and also the frequency and again is here, the displacity is considered according to your the less than point on, and another is the less than 1.24, and also the energy is considered the less than 120. The similarly we have to find during to this the different color is here. According to this, the red color is considered according to the color wavelength is considered according to the 700s, and also your the frequencies comes here 428, and also the 140 1.43 1.77 171 is here. Similarly your the green color is considered according to this 530, and also the 566 1.89 2.34 and 2.26 is here, and the cyan color is comes that like your the 500 600 etc. And also the violet visible is considered is the 420 and 7 1/4, and also the 2.308 and also 2.95 and also 2.85 is considered according the color of object. And the color of an object depends on both the physics of an object in this the environment and the characteristics of the perceiving eye and brain is considered according to your the color. And basically you have to depends on your the brain as like as your this eye, then you have to given seen a object, and also you have to given this color is here, and which color you have to consider according to this, and this will be creating object, the color is here. The physically objects can be said to have the color of the light living, that lies there the surfaces is here, that is the living this the light is living from this the your surface, the which normally depends on the spectrum of the incidence illuminations is comes here, and the reflectance properties of the surfaces, that like the reflectance properties of the surfaces come here, as well as potentially on the angles of illuminations and viewing is comes. The some objects not only reflects light, that is a few objects here, that is a not only reflect the lights but also transmit light also, that is the transmit these lights or emit light and themselves, that like the three cases will be comes on this the object is here, that is the only the not only reflects light, the this also the transmits light, and also the emit light is themselves is considered, which also contributes to the color. This one will be contributes the to the color. A viewer's perceptions is comes of the object, this is the a viewer's perceptions of the object's color depends not only on the spectrum is considered, that is the your color depends not only on the spectrum is here of the light leaving its surface, that like your the light leaving its surfaces, but also on a host of contextual cues is here, that is the host also the contextual cues, so that color differences between object can be discerned is here, that like your the mostly independence of the light spectrum is comes here, that is the your light is the considered according to your the independent spectrums, the viewing angle etc. also will be considered according to this. This effect is known as color constancy is considered. That according to your the color is given, that like your the constancy, that is the your objects will be fully viewing angles or this. You can see some generalizations of the physics can be drawn neglecting perceptual effects for now is here. That is the light, that is the arriving at an obfuscus is here, that like your the surfaces is either reflected and also that is the spectrally is here, that is the scatters or observed or some combinations of these is considered is here, that is your the realizations. And opposite objects that do not reflect spectrally have their color determined by which wavelengths of light they scatters around only the strongly, that is your the scatter is comes here, that is the strongly if object scatters all wavelengths with the roughly equal strength is come, that is your the object scatters all wavelengths with the roughly equal strength, they appears with the white colors. And another things, if they absorb all wavelengths, the appear black is considered. That like your the previously already known according to your the class 11 when we read this the different lights. The if object scatters all wavelengths with the roughly equal strength, that is the appear white color is comes. And if they observe the all wavelengths, they appears the black color. The upper cube, the objects that spectrally reflect lights of different wavelength is considered. The with different efficiencies looks like the mirror tinted with the color determined by those differences is considered. An object can reflect object that reflects some fractions of impinging light and absorbs the breast may look black, but also be be faintly reflective. And the examples are black observes black object coated with the layer of enamels or lacquer is here, and also this is the lacquer will be considered according to your the here. The objects that transmits light are either translate and or the transparents will be considered. That like your the object that is the transmit lights are this is considered according to your the translucent also the transparents. If they also observe the observed lights of various wavelengths is considered, the wavelength is comes from your the differentially. They appear tinted with a color determined by the nature of that absorption is considered. The objects may emit lights that they generate from having excited electrons rather than merely reflecting or transmitting light is comes here. The electrons may be excited due to elevated temperatures as a result of chemical reactions is comes here after observing lights of other frequencies is considered according to the fluorescence or the phosphorescence will be comes here. That is the this will be comes that like your the elevated temperatures will be comes here, that like your the fluorescence or phosphorescence is here, or from the electrical contacts as in light emitting diodes or other light source is comes here. You can see here the this will be the on picture is given, that is the upper disc and the lower disc. This is the have exactly the same objective color is come at the and are in identical gray surroundings is considered according to here, that like your the based on context differences is considered, that is the different context is here. And the humans perceive the squares as having different reflectance is considered is here, and may interpreted the colors as different colors categories. Say checkered shadows illusions is come here, that like your the different shadow illusions, that like your the upper color is the on behind shadow is comes, and in front of this is the on context is find here. You can see that is your the additive colors. The additive colors mixing, that like your the combining red and green yield yellow, that is called the, you can see the three color is here, G R B is here, that like your the red and green yield is the yellow is comes here, that is the combining all three primary colors, that like your the three primary colors together yield whites will be considered. You can see in your figure is have to consider according to this the white colors. And another things, the additive color is here, that like your the what is your additive colors, and that is the light created by the mixing together light of two or more different color is considered, that like your the two or more different color is comes here. And basically you have to given in this figure, that like your the additive color mixing is the combining red and green yield yellows, and that like your the combining all three primary colors together yield white is comes here, that like your the this picture is given. And another thing is the additive color is light created by the mixing together light of two or more different colors, that like your the red, green and blue are the additive primary colors normally used in additive color systems, that like your the primarily may be used during your the additive color system, such as an projectors and computer terminals will be seen. You can see that like your the projector as your the computer terminals, you can see the this type of object will be here, that is the three more different colors is comes, that like your the red, greens and also the blue, and you have to consider according to your the primarily colors normally and used in this the additive color system is considered. The subtractive colors. The subtractive colors, the coloring uses dyes, the inks, the pigments or filters to absorb some wavelengths also will be here of light and not others is comes. The color that is surface display comes from the parts of the visible spectrum that are not absorbed and therefore remain visible is comes here. You can see the different concentrations will be considered according to this. Without pigments you have to consider or dry or dye is here, that like your the without pigments or the dyes. And another the fabric fibers, you can consider according to this the fabric fibers. The paints, base and paper are usually made of particles that scatter the white light. All colors is comes during to this, that like your the white lights, that means this will be passing through this the all colors, and also this is the not absorption of his this is considered the white colors, the all colors well in all directions according to this the all directions. When a pigments or link or ink is added, that means your the ink is added, wavelengths are absorbed or subtracted, that like your the these inks are added, some wavelength is the added or the subtracted from white lights. The so light of another color reaches the eye, that means reaches the eye, and this will becomes during to this the subtractive color mixing, that is the combining yellow and magenta, and the yield rates will be here, and combining all three primary colors together yielding black is considered, that is the black shape will be figured, that means your the picture. And you can see here that like your the if the light is not a pure white source is considered, that is the you have to the pure white source, that means the all rays the comes out. The case of nearly all forms of artificial lighting is calm, that like your the artificial lightings, the resulting spectrum will appear a slightly different color is comes. That like your the resulting spectrums will be comes here. That is your the slightly different color. Red. Also the paint is here. The viewed under blue lights may appear black. That like your the blue lights. This is the appear this black. Red paint is red because it scatters only the red components of the spectrum. That means you have to comes here. That is the different color is comes, and also you have to consider the different spectrums is here. If red paint is illuminated by blue lights, that means your the red is the illuminated by the blue lights, it will be absorbed by the red paint, and again the creating the appearance of a black object is considered. That means you have to passing through your the red paint is illuminated by the blue lights, it will be absorbed by the red paint and creating the appearance of a black object is considered. The structural color is comes here. The structural color colors are color caused by interferences effect rather than by pigments. And another thing is the color effects are produced when the materials is scored with the fine parallel lines. The form of one or more parallel thin layer is comes here, or otherwise composed of microstructures on the scales of the color wavelength is comes here. That is your color wavelength. If the microstructure are spaced randomly, and also the light of shorter wavelengths will be scattered the professionally to produce the Tyndall effect color is comes here. That means your the Tyndall effects. The blue of the sky, the luster of opals, and the blue of human rays is here. And if the macrostructure are aligned in array, for example, the array of pits in a CD, they behave as diffractions. Grating is considered. The grating reflects the different wavelengths in different directions due to the interference. The phenomena separating mix white the lights into light of different wavelengths is comes here. The structure is one or more thin layer is comes. That means then it will reflect some wavelength is considered, and the transmits other depending on the layer thickness is comes here during toward the structural color. That means you have to given to your the structure. That means your the layer by layer. That is the reflect some wavelengths, and also the transmit other depending on the layer thickness is comes during to this. You can see the this will be the classification of pigment colors is come is here. That is the first is considered according to this the primary, that is the yellow, red, and also is comes is blue. The secondary is comes here, that means your the orange, green, and purple is considered according. That is your the secondary is come here, that means your the orange, green, purple is comes, and the tertiary is considered is the that means your the citron, russets, and also bulb will be considered is here. That means your the yellow, gray, and the radius gray is here. That means your the blue gray is considered, and the quaternary is comes here. That means your the palm original gray is here. That means your the olive, and also spa is considered according to your the classification of the pigment colors. And that means your the additional terms will be here. The color wheel, the illustrative organizations of color hues in a circle that shows the relationship is here. That is the colorfulness, the chroma purity is here, or the saturations, how intense or the concentrated a color is. The technical definitions, the distinguish between the colorness, the chroma, and the saturations as distinct, the perpetual attributes, and the includes purity as a physical quantities is considered. These terms and other related to the light and colors are internationally agreed upon the published in the CIE lightings vocabulary. And dischromatisms is here. The a phenomena where the hue is depends on the concentrations and thickness of the absorbing substances is here. The hue, the color directions from the white, for examples, in a color wheel or the chromaticity diagram is considered. Another is the shade, a color made darker by adding black. The tint, a color made lighter by adding white is here. And value and brightness, lightness or luminosity is here. That is the how lights or dark a color is here. Thank you, students.